This is Mr. V. Welcome to this video on gradients. Here's a common problem that you might get. We have some kind of hill set up, and on this hill we've placed two poles a certain distance away, in our case 120 meters, and we have attached to both poles a string that indicates the height that that string is at. And what we want to know is what is the gradient or the slope of the land here. Alright, now our definition of gradient, put it down here, gradient equals, and we use either rise over run or vertical over horizontal, whichever one you prefer. I prefer this one, vertical and horizontal, but that's just me. Alright, now in the situation of this problem, the horizontal is pretty easy to figure out. We know that these poles are 120 meters apart. But we need to do a bit of working to figure out how much vertical rise our land has. So how much the land moves up. From the ground here up to the string, we have 8.04 meters. I know, big pole. On the other end, it is 1.28 meters back down to where the ground is there. So hopefully you're able to see that going up this side and down this side leaves us with the rise of the land. So we can calculate it by simply going 8.04 minus 1.29. Let's calculate that. And we get 6.75 meters. And that's a vertical, 6.75 meters. Now a gradient is simply going to be 6.75 divided by 120, and putting that on our calculator is going to give us 0.056, and that has no units. And that's great. Sometimes we might go an extra step further though and ask you for the angle of elevation. What that is it's simply the inverse tan negative 1 of the gradient. And you'll quite often see the rule written as tan negative 1 of the vertical divided by the horizontal. In our case, that is going to be tan negative 1 of 0.056, and if I use my calculator there, inverse tan, we get about 2 degrees. So this land slopes downwards at 3.2 degrees. And that is how we can calculate the gradient and angle of elevation for a piece of land.